Okay, well, so my little session here has run where I changed the filtering parameters. And what I was interested in was a different type of disturbance, slowest loss. Now the layers that come out are the same. So we've got year of detection, magnitude, and duration. So let's look here. We've got different colors this time, not red. We've got blue and yellow and orange, etc. And so again, if I want to click on let's say a blue pixel, it will tell us what's there. Give it a second. So again, I'm looking in the upper right inspector output window, a year of detection of 1987, a magnitude of 56, and a duration of 36. Right, so it's a segment that is going for the entire time series. And one of the nice things about this interface is that I can close my change filter options, go back to the pixel time series options, and just start looking around in some of these different areas and pick pixels that have experienced a long duration change and actually see what we're seeing. Like we can see what we're mapping. So a common sort of way to use this is to experiment at the pixel scale with some of the places that you know about, come up with a recipe for Landtrender, run it in this mode, look at places where things look weird or they look like they make sense, etc. And then potentially alter your parameters, go back to the pixel time series, play around with those until they fit the way you think they should, and then rerun a mapping output, for example, and keep going that way. Let's click on a place that's sort of intermediate in duration. So it's hard to see this. I'm going to click on a green area. I'm hesitating to zoom in, which probably all of you are just anxious for me to do. But if I zoom in, one of the things that will happen is that Earth Engine will just rerun the entire thing, which will take a couple minutes. And so I'm trying to avoid that here. But so here's a pixel that had a sort of a step change where there was a disturbance, relatively low magnitude, and it had a long decline here and another long decline. And if we go to our inspector, it will tell us a duration of 18, a magnitude of 52, and a year of detection 2005. And that corresponds to this last segment here, which the endpoint is 2004. The first year that it could see anything happening was as the year after when it started to decline. So it reports this as 2005, and it says an 18-year segment. So this particular segment has been declining since this whatever happened. And I believe this was a fire. But you can sort of play around with the magnitude. Here's a patch of green, which is we'll let the pixel run here. So here, the greatest decline was from 1987 to 1995, and this I happen to know was an insect outbreak that slowly defoliated and killed the trees. So it took several years, and I'm mapping the slowest change segment that looked like disturbance. So in this case, it would be this one that started in 1987 with a magnitude of 370, etc. So when you're doing this once you've played around with this and you sort of feel like you've got the right recipe, you can then download these things. And so there are instructions about how to actually download this. There's a little help thing in the upper right here that tells you how to do that. I won't go into that in detail. You can read that yourself. But you could download the change imagery, other pieces. One of the key things to think about, though, if we go back to, for example, our year of detection map, is, okay, we've got a map. How do we know how wrong it is? And I specifically say it that way because all maps are wrong. Really, if you're going to use this for any sort of official purpose, a planning purpose, a reporting purpose, etc., you need to think about how to do interpretation at some sort of sample to characterize the rightness or wrongness of your map. The way you define this, the way you run the sampling design, etc., is sort of beyond the scope of this particular tutorial. There are tools, time sync, time, and then SYNC, time sync, is a tool that we co-developed at the same time with LandTrender many years ago. There are different versions floating around out there online. We have a tool called TimeSync Plus in our own lab. These are all tools to look at the entire time series and try to validate some of the change. There are other ways to build validation data sets with, for example, Collect Earth Online, that look at specific kinds of change, and you can tailor your sampling design there. So a much bigger topic, a super important topic. The fact that we're not talking about it in detail doesn't mean it's not important, but that would happen after you do some mapping. The other piece to remember here is that, as you're doing this map, again, remember this reflects what the algorithm found based on the fitting parameters fit to your image collection and the time of year, etc. So if you get a map like this and it doesn't look like it's capturing what you want to do, then you go back to the pixel time series, you click on the place you're interested in, you say, oh, okay, the reason is maybe the Landsat archive is not, maybe you don't have the right time of year to pick the thing you need. Maybe it's just too subtle. Or maybe the algorithm has parameters that are just ignoring something that should be there. This interface allows you to query pixels, plot the time series, and adjust the LandTrender parameters so that ultimately you can make a better map. And I think we'll stop there and entertain any questions. Those of you watching the video, please, I encourage you to look at our, if you Google LandTrender GitHub GEE, you will find the link to our training documents that point out, again, and give you different scripts as well as pointers to this user interface as well as other ones. And you can take those scripts and you can adapt them to your own use case once you've found the right recipes. With that, I think I'll close. Thank you all for your attention. I appreciate it. And I wish you well finding and telling the stories of pixels on the planet.